In this video, we're given a function f of x is equal to x minus 3 over 2x plus 5, and we want to use that to find the f of the f inverse of 0. And so we need to first of all figure out what the inverse is, and then we can talk about composing the functions, and then of course plugging 0 into the place. But we're actually going to use a shortcut once we do find the inverse. So let's go ahead and do that. So finding the inverse of f of x, the first thing we're going to do is replace f of x with y. So we're going to rewrite this as y is equal to x minus 3 over 2x plus 5. And then the second step is to switch all of your x's to y's and switch all of your y's to x's. And so when we do that, we're going to have x is equal to y minus 3 over 2 times y plus 5. And then the next step is we need to solve for y. Now the problem here is we have a y in the top and in the bottom. And so we need to get the y out of the denominator before we can actually solve for y. So this problem is going to get a little bit worse before it gets better. To get it out of the denominator, we need to multiply both sides by 2y plus 5. Be sure you put that in parentheses on the left-hand side, especially. And so now if we distribute on the left-hand side, if we distribute the x, we're going to have 2xy plus 5x is equal to y minus 3. And so now in order to solve for y, we need to get all of the terms with y on one side of the equal sign, and then factor, and then divide. And so what I'm going to do is I'm going to subtract y from both sides, and I'm also going to subtract 5x from both sides. And so we're going to cancel there and there. So subtracting y from both sides, on the left-hand side, we're now going to have 2xy minus y, and that's going to be equal to negative 3 minus 5x on the right-hand side. Now factoring a y out of both of our terms on the left-hand side, we'll have y multiplied by 2x minus 1, because when you divide the y away from 2xy, you're just left with 2x. When you divide y away from itself, you're just left with the 1, and the negative sign sticks. And on the right-hand side, we don't change anything. It's just going to be minus 3 minus 5x. And now, in order to get y by itself, we can divide again. We'll divide both sides by 2x minus 1. 2x minus 1. And so that's solved for y. So I'm just going to go ahead and rewrite that. Instead of y, I'm going to say that's f inverse of x is going to be equal to negative 3 minus 5x over 2x minus 1. And so that's our inverse function. So that's kind of the first step. That's just figuring out what this inverse function is. But this problem wants us to go a step further. It wants us to find the f of the f inverse of 0. Now, what I'm going to tell you now is kind of this little trick, because anytime that you compose a function with its inverse, you technically know that the answer is going to be equal to x. So, for instance, f composed with f negative 1 of x is just going to be x, and vice versa. The f inverse of the original function f of x is also going to be x. That's part of the requirement for a function to be an inverse of the original function, whatever the inverse function is. If two functions are indeed inverse of each other, then you can compose them both ways and you're going to get x both times. And so now what you're probably saying is, why did we even have to find the inverse if we know that? Because technically we know that the f of the f inverse of 0 should just be x, but if you put a 0 in the place of x, you just get 0. And the answer to the question why I would make you go through this is you don't actually have to. I was showing you all the work that you would have to go through, and then if you just did this algebraically, then you would have to plug this function right here into the original function in the place of x everywhere you have x. And what's going to happen after you do that is it's going to simplify to just x. And then you plug 0 in the place of x and you get 0. So I wanted to show you kind of the long way, which really we only did half of the long way. You'd still have to compose the functions, and just to show you that that's really not necessary. Now, of course, if you had to find the inverse first of all, then yeah, you'd still have to go through all that. But if you ever are given a function and you want to find the f of the f inverse of a number, say 0 or something like that, you know that the answer, the composed form of the f of the inverse, is just going to be x. And then whatever that value is that you're plugging into the place of x, that's just going to be your answer. So there you go.